Basically, the entire algorithm is represented by this equation, and as you can imagine, this cryptographic equation has its own assumptions and has its own limitations. So now let's discuss about all these assumptions and limitations. So this is the picture that happens behind the screen about encryption and decryption. Before user and the Amazon, the company, goes on to transfer data in between them, then they assume that they already have a secure channel, they already have a secure network that they can use. But unfortunately, that's a limitation, and that cannot always happen, because if they assume that all the networks are secure, then an intruder can get in and hack or steal that data. It is also assumed that this cipher which the sender and the receiver is using to encrypt and decrypt the message exists in predetermined form with both of these nodes. It does not ensure whether this cipher is lost or whether this cipher actually exists with any one of these nodes. So a problem arises when the company Amazon has more than one customer. So if it decides to use this same cipher for many of its customers, like the first customer it comes is called the U1, so it goes on to use the cipher C1 with U2, it also decides to use C1, then intruder disguised as the user may exploit the system. So this is a really big issue. Then when the company decides to install new ciphers for each of its customers, like C1 for U1, U2 for C2 for U2, then if a third customers come and this customer has C3, then the system will grow huge. It will take a vast amount of space just to store these ciphers. So what is the get around for this problem? The get around for this problem is to use a key that will actually represent the cipher or algorithm, rather than the receiver and the sender storing around or carrying around the entire algorithm. A key is definitely a value, a string of random values. So insofar, we have learned that there are two main assumptions. So what are the assumptions? It is assumed in general cryptography that the network may be secure and it can be used, although there is no guarantee that the network can be secure. And the second assumption that is made is the cipher exists in predetermined state with both the parties, or the receiver and the sender. So when the company decides on to use these keys to encrypt and decrypt the data, it will also save their storage spaces, and hence, as the computational power grows, queues can grow many times larger. So as the keys grows or the key space grows, it gets harder to crack them, and an intruder, an outsider, cannot crack that key easily. And the second advantage over the first one is that the cipher doesn't need to be carried out around, and the cipher, a single cipher, can be stored in the background, whereas different keys with different string values can be handed out to each of these users, but the inner ciphers remain the same. So one key for only one user, and only one cipher or only one algorithm for the entire encryption and decryption system. When you start talking about this symmetric key cryptography, or in short SKC, we must remember that this cryptography relies on the key mechanism that we have talked about in here. Perhaps there are three types of key cryptography that relies on the key mechanism. The first is this one, SKC or symmetric key cryptography. The second one is the AKC or asymmetric key cryptography, and the third one is the hybrid key cryptography. We'll gradually talk about all three of them. So first let us start with this SKC. So what is this SKC or symmetric key cryptography? In symmetric key cryptography, we find that the receiver and the sender, both the parties or both the nodes, share a single key. They share a single key and a single cipher that is represented by the single key. So this can be understood through a demonstration or through an example. In this example, we see that the user U and the Amazon, the company A, goes on to interacting with each other using the symmetric key system cryptography to encrypt and decrypt the data. So let's see how this process works. First, A tells to U that Mr. U, I have this crypto system and this cipher, will you accept it? And that occurs after user U has requested to A that I want to buy something from your store. So after the message has been sent, this second message from A requesting an agreement about its cipher goes to U, and U agrees on it. Then second of all, U tells A that, is there anything that I need to do anymore? Then A tells U that we have a key that represents that cipher. That cipher needs to be stored inside your computer, but this key needs to be used every time you want to purchase something from our store. Then again, U goes back to A and say that, is there anything else that I need to do? Then A says no, there's nothing else. Then U, the user, encrypts his message or encrypts the data that he wants to send. It means that he sends the message that I want to buy a book to A, and then A goes on to decrypting that message for itself into its plain text form. Now this entire system can be represented mathematically. It's almost the same, just a slight difference occurs. So mathematically, this is represented as equals to M. This is very similar, but this system has its flaws and major drawbacks. So let us assume that this system works fine among only this single pair, but what happens if more and more users starts to come in and tells the company that I want to buy something from your store? Suppose that U2 comes, or user 2 comes and tells Amazon or A that I want to buy a router from your store. So what this A does, he needs to create more and more ciphers, more and more keys to provide for each of its customers. So if there is another customer requesting to buy a dress, for example, if U3 comes up and requests to buy a dress, A needs to provide another pair of cipher along with its corresponding key. So you might imagine well that this is a very tedious job, and obviously this needs a huge storage. The main drawback in this system is that both of these parties, both of these nodes, if we consider only this U and A, these parties or these nodes assume that the connection or the network that they're going to use is already secure. They don't want to, they don't ensure whether the network is actually secure.